Hi, I know it's been a while since we've had to watch a video. Now that we're done with transformations, we're going to look at congruence. Your essential question, how can we determine congruence and similarity? And then your I can statement. So what you want to make sure that you can do by the end of the lesson, I can define congruence in terms of rotating, reflecting, or translating the first to obtain the second. Congruence is if two figures have corresponding sides and angles that are congruent, which means they're the same. So congruent figures are the same shape and the same size. So again, the corresponding sides and the angles are going to be congruent if the two figures are congruent. Corresponding parts are the parts of the congruent figures that match or correspond. So they're in the same orientation of the figure itself. For instance, let's look at this example here. We have triangle ABC and triangle DEF. Our first congruence statement here says that triangle ABC is congruent to, that's what that symbol means, triangle DEF. And that congruent symbol is an equal sign with a little squiggly above it. So when you see that symbol, that means is congruent to. So we're going to look at triangle ABC being congruent to triangle DEF. Since that statement is telling us they're congruent, we can make congruent statements about the corresponding sides and the corresponding angles. For instance, right off the bat, we can see that angles B and E are corresponding because they're both right angles. They both have that 90 degrees. So what you want to do is make sure you are picking corresponding angles. You can't just say angle A is congruent to angle E, okay? Because those two are obvious. We want to make sure that we're picking corresponding, which means they're in the same place in the shape. Sometimes you got to take a little bit of time and look at those just to make sure. In this example, angle A is congruent to angle D, angle B is congruent to angle E, and angle C is congruent to angle F. These little slanted looking L's, that means angle. Then we can also look at the sides and give congruent statements about those. Side AB, which is this vertical side here, is congruent to side DE, which is the other vertical in the second triangle. Now, one thing you want to look at in your statement, if you notice, A and D are in the same place when we name those triangles. So when you name these triangles, or when you're given the name of the triangles, they're kind of giving you a clue as to what angles correspond with each other. So we know A and D are going to correspond. That means that AB has to correspond with DE. Side BC corresponds with side EF. And side CA corresponds with side FD. You do need to be very specific when you name these. They do have to be consistent and correct. So make sure you are matching those corresponding parts when you name these or list these congruent statements. Okay, we're going to do an example. We have trapezoid MNOP congruent to trapezoid WXYZ. So we know they're congruent. It's given to us in the first statement. Now what we're going to do is list our side and angle congruence statements. So we're going to look at our two figures, and in this case we have trapezoids, and we want to make sure that we are corresponding or matching corresponding angles and sides. Let's start with the angles, and I'm going to start with angle M. Looking at either the name of the second trapezoid or the trapezoid itself. Now this one's rotated a little bit, so we're not going to match M with X just because that's the top right or top left corner. You've got to make sure you're picking corresponding angles. So for instance, in this case, M actually corresponds with W. And if you notice in the name, they're in the same location when they're named. So angle M is congruent to angle W. Angle N is congruent to angle X. Angle O is actually going to be congruent to angle Y. And then angle P is congruent to angle C. If you notice, that's the acute angle, so I would definitely make sure those are matched up. Okay, now let's look at our sides. We have side MN, and we put a little segment bar over there because it really is just a line segment. So side MN is going to correspond, and if you notice in the name, MNWX. So it's congruent to WX. Side NO is going to be congruent to side XY. Side OP, just this long side here, is going to correspond and be congruent to YZ, the other long side. And the last one, side PM, so we're going to close it up with that diagonal side, is going to correspond and be congruent to ZW. Now, since this is a four-sided figure, we're going to have 4 angle congruent statements and 4 side congruent statements. In our last example, we're going to take it into the coordinate plane where we're looking at transformations. Remember what we talked about when we looked at transformations. If it's a translation, a reflection, or a rotation, your figure's shape or size doesn't change. So when you translate, reflect, and rotate, you will still have the same shape and same size. That's congruency. So after a translation, reflection, or rotation, you're still going to have a congruent figure. That's what we're going to kind of look at now. We have triangle RST, and it's congruent to triangle XYZ. Reach that. All right, so if you notice, something has happened when we went from triangle RST to XYZ. What happened is a reflection over the x-axis, and then it translated. So what you want to be able to do is look at those figures, notice that they are congruent, and then you have to be able to tell me what happened as far as the transformation. Since the orientation has changed, that means that it's not just a translation. It could be a rotation or a reflection, because in those two situations, the orientation will change. The size, remember, does not. So in this particular situation, we started out above the x-axis, we then reflected over it, and then it kind of translated or slid a little bit. So what we want to do is make sure that we are able to describe what happens and give your congruent statements for your sides and your angles. So when we get back to class after watching the lesson, we'll do more examples of this, so make sure you have your graph paper. Thank you.